Okay, so next point or second point from this chapter electromagnetic waves is Maxwell's equations. So Maxwell equations are the basic laws of electricity and magnetism. So there are four laws. First law or first Maxwell equation, it is based on Gauss law of electrostatics. So what is this law? This law already we have studied in the first chapter, that is in the electric charges and fields. So what is this law? That is total electric flux for any closed surface, it is equal to what? 1 upon epsilon naught times total charge enclosed in that surface. So it is known as what? Maxwell first equation. Total electric flux for any closed surface, it is equal to 1 upon epsilon naught times total charge, that is Q, enclosed in that surface. If the charge enclosed it is 0, then total electric flux also will be 0 for that closed surface. Now the second equation of Maxwell, it is based on Gauss law of magnetostatics. So according to this law, there is magnetic flux for any closed surface, net magnetic flux, it is equal to what? 0. That is for any closed surface, total magnetic flux is always 0. Okay, so it is known as what? Second law, that is a Gauss law of magnetostatics. It is also known as a Maxwell's second equation. Third equation, it is based on Faraday's law of electromagnetic induction. So what is Faraday's law of electromagnetic induction? So due to the change in the magnetic flux, what is getting induced in the circuit? EMF. That is, when we change magnetic flux, due to that change in the magnetic flux, EMF is getting induced in that circuit, and direction of both, that is changing magnetic flux and induced EMF, they are opposite to each other. Therefore it is written as change in the magnetic flux, that is d by dt of phi b, where phi b is the magnetic flux. Negative of that, it is equal to what? Total EMF induced in the circuit. So it is known as a Faraday's law of electromagnetic induction, and which is also known as a Maxwell third equation. Now we'll go for the Maxwell's fourth equation, that already we have studied. That is nothing but as per the displacement current. In first derivation we got displacement current and we modified the Ampere circuital law to Ampere-Maxwell circuital law. It is also known as a modified Ampere circuital law. So it is same, that is a closed integral of or line integral of total magnetic field for any closed surface. It is equal to what? Mu naught times total current threading that loop. That is for any loop. If we consider total magnetic field, it is equal to what? Mu naught times total current. And total current, it consists of what? Both conduction current as well as displacement current. And displacement current is produced due to what? Change in the electric flux, which is d phi e by dt. So epsilon naught into d phi e by dt is the displacement current. So put the value of displacement current in this equation, we get the Ampere's Maxwell circuital law, which is also known as a Maxwell's fourth equation. Understood? It is nothing but what? Total magnetic field, that is a closed integral or line integral of total magnetic field for any closed loop, it is equal to mu naught times total current threading through that loop. So it is regarding your Maxwell equations. Thank you.